Okay, so let's just get started with this question. So let's do the homework first. So problem 15 states, what is the 199th digit of the decimal representation of 3 divided by 37? Well, first of all, one quick way is to just find the decimal representation itself. For example, basically, all you do is just go over, just continue putting in numbers. Like, for example, notice that uh 111 is equal to 3 times 37, and then 999 is equal to 9 times 3 times 37. There's a trick to finding repeating decimals, but first, notice the 37. 37 is actually 9 times 3 times 37 is equal to 999, which is a good thing because then repeats. We just need to multiply by 9 times 3. Or from that, if you multiply 9 by 3, you get uh 9, oops, 9 times 3 it gives you 81. So it repeats like this, 0.081. It repeats like this. Because we want to make 337 equal to n divided by 999. And then from there, you can make it so, and multiply by 27 gives you the desired result. And then so the 199th, we want to take this and remember it cycles of 3 every single time. Cycles of 3. So you just basically want to find the remainder when 199 divided by 3. And then add this on to number. It'll be 1, 2, 3, or 1, 2, 0. Okay, so basically 199 divided by 3 is equal to basically, remember, yeah, it's basically equal to 1 mod 3, or it has a remainder of 1. So basically, we want to find the first term in that cycle, which gives 0. First, second, third, with 0. So now let's do to problem 16. What is the 125th digit beyond the decimal point of the decimal representation of 4 divided by 7? First, you can make a really good estimation that 4 divided by 7 is like around, if I actually plug it in the calculator, the answer is actually going to be 0. It's actually going to be 0.57142, I think, right? C equal to 0.57142, I think. Yeah, it's because of cycles. Anyways, from there, you want to find the 125th digit, which is basically going to be 2, because 2, why? It's because it has 100, it's the 125, and the least possible multiple of 6 such that uh 120 it's greater than 125, meaning that 6n for some random number n is greater than 125. That happens when 6 it's 6n n is actually greater than 125 by 6. So the least integer is gonna be equal to 36, because the next to 125 is 126, which is divisible by 6. So from there, you know that it's going to be the second to last number in the cycle, which means it's 2. And then problem 17 states the positive odd integers are arranged in 5 columns, A, B, C, D, E, continuing the pattern shown. In which column is will 1,599 appear? So we have 3, 5, 7, 9, 11. That's the first. Oh, 1, 3, 5, 7, 9. Forgot about 1. Sorry. And then 11, 13, 15, 17, 19. Notice that the numbers that end in a 9 are in one column, namely E, D have all numbers that end in 7. C has all numbers that end in 5. B has all numbers ending in 3. And A has all numbers ending in 1. So what does this 1599 end in? 9, which means it's in column E. If you can deduct from there. Wait. Oh, I'm sorry. So basically, it repeats every 5 integers. I'm gonna check for a second. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Positive odd integers in 5 columns. Oh, the columns are not given, so sorry for a second. Seems like the columns were not given. It looks like this. Sorry. So I didn't see the diagram, so I got the answer, which was wrong. E. So it's good to see the diagram. You could learn from mistakes. A, B, C, D, E. So from there, you can see that there's 1, 3, 5, 7, 9, 11. Nine, 11, 3 goes to, oh, oops, sorry. I mean, this is 15, 13, 11, 9. And then it goes back in an example, goes back to 17, 19, 21, 23, and so on. So 23, then 25. Oops, I mean, this is 25, 27, 29, 31. Like that. So basically, from there you can get out that one. It repeats every 8 integers. So it'll be 1, 3, 5 going in one way and then comes back in another way. Increases to left to right and then right to left. So basically 1599. So basically 2 times n minus 1 has to be equal to 1599 because it repeats every 8 integers. But for this one, we want to find which odd number it is. So basically, it's gonna be the 800th odd number. Because every 8, so it's gonna be in the because 1, 2, 1, 3, 5, 7, 9. I mean, 1, 3, 5, 7, 9, 11, 13, 15. So 8 is gonna be an A. So every 8 is gonna be A. So the answer is gonna be A. Problem 18. The multiples of 3 are arranged in the following manner: 3, 6, 9, 12, 12, 15, 18, 21, 21, 24, 27, 30. In which column will 1992 appear? Notice that all even numbers that are all multiples of 3, obviously, are going to be at column 2 or column 4. Now, basically, notice that it's going on double. 1, 2, it repeats every 2. That's 12, 12, 30, 36 can be said twice. While 6, 18, 24, 36, 42 are not said twice, and they're increasing. But look, 12, 6, 12, and over here plus 6. So what can we pull out of this? Well, notice that we can just try to see, and we notice that is the first, and that's the fourth, multiple of 13. That's still the fourth. It's the seventh, and then that's the seventh. That's the 10th, 10th, 13th, 13th, and so on. So it'll be in a pattern of 1, 4, 7, 10, 13, and so on. The columns 4. So it'd be n, 3n, basically 3n plus 1 times 3n minus 1. I mean, n, sorry. 3n minus 1 plus 4. So the first one, oops, sorry, times 3. That's gonna be a term. If it's gonna be inside 1 or 4. So is 1992 in that? So what is 1992 divided by 3? First thing I want to know that. That's equal to 664. First find out 1992 divided by 3, which is equal to 664. And then from there, we want to see if it is following this pattern. If we divide, so it wants to see if 664 is equal to that. Is it possible? Yes, 663 has to be divisible by 3 and n minus 1, which is impossible. Oops, I'm sorry. I mean, no, it is possible, sorry. 663 is divisible by 3 times n minus 1. So dividing gives us n minus 1 equals 221. Oh, n is 222, which is indeed even. So it's an even. So 1992 is even, and it's indeed in one of these columns. So it has to be in column 4, which means the answer is the 4th column. Natural numbers from 1 to 1,000 are arranged consecutively from left to right in a triangle shown below. Each row contains one more number than the row above. What is numbers directly above 723? Notice this actually shows a sequence it's known as triangular numbers in the form of n times n plus 1 divided by 2, or the sum of the first n positive integers. So this is the third triangular number, fourth triangular number, and this is the fifth triangular number. So notice that we can flip the arrangement, make it go this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on. Notice that it increases by 1, then by 2, then by 3, then by 4, and so on. So we know that the sum of the first n integers is equal to this. So notice that 37 times 37 plus 1 divided by 2 is indeed equal to 703 and less than 723 and is less than the next triangular number, or 741. So it goes 20. So 20 is going to be 61. The difference is 20. So in 741, that's the last. That's going to be the new last number, technically. Plus 20 gives us 761, which means 761 is our answer. Same difference. This is 20, so that number n has to also be 20. So from there you get that. Now we can jump into problem 20. The triangular numbers can be represented in a triangular way. For example, 1, 3, 6, as we talked before. The difference of a pair of consecutive numbers in a triangle is 12. Find the sum. So let's do a general approach. So we know the nth triangular number is n times n plus 1 divided by 2. The n minus first triangular number is equal to n times n minus 1 divided by 2. Just plug in n minus 1 into this formula. right over here. We'll get in this formula right over here. And from there, you get that. We subtract it with generality. You get that. That n squared. The n squares cancel out, and we're left with 2n divided by 2, or equal to n. So from there, you get that the difference of two consecutive triangle numbers is 12, which means one of them is 12 times 12 plus 1 or 13, or equal to 78. Another one's equal to 12 times 12 minus 1, which is equal to 66. Added then up gives us 144, which is indeed right. Because that's one way you can use the Newton's little formula, but I feel like it's like kind of hard, and like I honestly don't like doing it. So, let's go to problem 21. Squares are used to build the following sequences of drawings. If the length of a side of each square is 1 unit, how many units are in the perimeter of the 8th drawing? And you can see, as before, this is a triangular number. 1, 2, 3, 1, 2, 3, 4, 5, 6. These seem like popping up everywhere in these problems. But anyways, if the length of each square is 1 unit, how many units are in a perimeter of the 8th drawing? So I learned this, and I didn't learn this in geometry class. And I figured out this small trick. I remember I learned it from somewhere. And that small trick, I learned that basically, you can just do over here. Complete the rectangle, basically. Complete it. Like this one. Complete the square, or rectangle, it depends. And once you complete the rectangle, notice that this length corresponds to this length. That length corresponds to that length. And this length also corresponds to that length. This length also corresponds to this length. So, if you have a figure like this, it's the exact same figure as the same figure, but completed as a rectangle, basically. If you know that, it's really fun. For example, in this one, is 1, 2, 3. Oops, I got mixed up. 1, 2, 3, 4, 5, 6, 7, 8. But then, imagine we completed that square. So it was a 2 by 2 square. It was like this, first like this, and completed it by adding a new square over here. Now we can count is 1, 2, 3, 4, 5, 6, 7, 8. It's the exact same as if you somehow you flip this along this line and you fill in the remaining squares. Just draw the rectangle out completely, and then you just find the perimeter of that rectangle, which is much easier. So for the 8th drawing, notice that the third has side lengths of 3. 1, 2, 3. Second has side length of 2, so the 8th has a side length of 8. So it's going to be something like this. Something like this. It's going to look like a diagonal square. And then from there, you notice that it's basically the same as the perimeter of an 8 by 8 square. If you were to draw it all out, which I won't, you just realize that it's the same as the perimeter of an 8 by 8 square, which is basically 8 plus 8 plus 8 plus 8, which is just 32. Okay, so it might have been confusing, but this is a really good formula just so you can just remember. And then when these problems are like trying to ask you for the perimeter and for a region, part of a length that you don't know, but instead it completes another length, and you find that rectangle, but we do know, it comes up, and which makes it really easy to solve many problems. Let's go to problem 22. Let's move it. At each stage, the midpoints of the sides of each unshaded equilateral triangle are connected and the triangle formed is shaded. Continuing in this process, What is the number of the stage where when the shaded area is first larger than 90% of the equilateral triangle? So basically, how we're supposed to solve this question? This question looks kind of tough, but notice that we've encountered some type of problem before. Notice that we can make recursion. So step 3, we just add these small triangles. How much is that? That's in total 9. FYI. If you guys know geometric series, it's gonna be good. You should search it up on the web to learn about it. About a common ratio. YouTube has many sources that give you a lot of explanations. So stage 1, it basically by congruency and similarity, you can get that this is 1/4. Okay, nice. 1/4. So from there, stage 1, 1/4. Stage 2. Now it keeps the original small triangle. So it's already 1/4. Plus these smaller triangles over here. Ignore the blue triangles for a second. They add these small triangles, which has the same area of this triangle right over here. But 1/4 of that. So it'd be 3. And there's 3 of them. So 3 times 1/4 squared. And the third one has these small blue triangles. I should do it like this. Yes, these small blue triangles, which becomes 3 times 3 of these, because there's 3 for the small shaded green triangles. For every one shaded green triangle, there's 3 of the blue triangles. So there's 3 shaded green triangles, and there's 9 shaded blue triangles, or 3 squared times 1/4 cubed, which is 1/4 of the 1/4, which is 1/16. 1/4 of that, which is 1/64. And then it happens so on. Good. Now we just discovered a geometric series. Well, these are the geometric terms. It's basically a geometric ray sequence with the combination of 3/4. We've learned that before. Now we know the sum of a finite geometric series, or it ends, unlike infinite. Okay, what do you not get? You can also look at past recordings, so it might clear up things, okay? So, but let's move on. So, the sum of a geometric series with A as a starting term, and every time you multiply it by R, like this, it has the sum formula of A minus R to the n divided by 1 minus R. So, we want to make it so that it's greater than 0.9. Of course, this is super hard to get. And honestly, I did it be ahead of time and calculated that it'd be n. If n is equal to A, then let's move this out of the way for a second. If n equals A, then this formula, the ratio is 3/4. So 1/4, that's the starting term, that's 1 minus 3/4 to the 8. I calculated. No need to use you can use a calculator if you want to, but sometimes you can calculate in your head if you're that smart, and I'm not that smart on calculating in your head super fast. Well, this is actually you can do 0.89987 887 0.8998887, and the next one's gonna be 9, which is just merely passes it, which is And if you plug in 9 and equals 9, it gives us 0.924915. So the answer is going to be 9. Okay, let's move on. If the shaded region shaded, if the pattern in the diagram continues, what fraction of the material will be shaded in the next triangles? I'll let you guys have a try and tell me what you get in the chat. Okay, so let's get started with this question. So far, 2 of you got it right. And so basically, the answer was D. And why? Basically, count. There's how many triangles are there? There's gonna be a 1, 4, 9, 16. It's basically the square numbers. And how many are shaded? The triangular numbers. One, I'm sorry. 0, 1, 3, 6, and so on. So basically, our ratio is going to be n times n plus 1 divided by 2n squared. So the nth triangle is going to have n times n plus 1 divided by 2n squared shaded. I think. Let's try it out. So for 1 times 1 is 2. Cancels it out. We get, oops, sorry. It's 2 times n plus 1 squared. Or 2n plus 1. That's better, I think. For 1, there's 1 divided by 2 plus 3. Still needs adjustment, so 4 is gonna be n squared. So be n plus 1 squared. Oh, maybe 2n plus 2. Sorry. And then from there, you get that n divided 2n plus 2. Plug in the 8, get 8 divided by 680, you get 8. 18 is equal to 4 divided by 9. So first, we know this formula for triangular numbers, which is n times n plus 1 divided by 2. And then we also know that we also know the basically the square numbers: 1, 4, 9, 16, 25, 36. Problem 24. As you proceed from term to term, each shaded square is divided into 4 congruent rectangles, and the upper left square is painted white. By following the pattern, what fraction part of a fraction of the 10th figure would be shaded? So basically, these are shaded. And then in this case, these are basically shaded. As you can see, this is going to be a geometric series, of course. Step 1, it has 1. Step 2, it has 3 divided 2 to the square. This will also be shaded. 3 squared and divided by 2 to the 4th. So basically, 3 to the n divided by 2 to the 2n. That's the pattern. Got that? And then, so plugging that in, gives us, wait, actually, it should be 3 to the n minus 1. That's even better. So if it's 3 to the n minus 1, divided by 2n minus 1, should be, actually, let's put it 2n minus 2. That's even better. Because we're going to be basically going the same rate as 3 to the n minus 1, but the exponent on 2 is going to be twice as big. So from there, then just, basically place 10 in, gives us 3 to the 10 minus 1, or 3 to the 9, divided by 10, which is 20, minus 2 is 18, so 2 to the 18th. And that's going to be our answer. So, I'll let you guys try to solve 25. And I'll show you the shading. Connected by the midpoints of the opposite side of the larger square. So, let me see. I think it's, this, then this, then this, and so on. And then you have to have, I think there's one over here. I'm not sure, but I'm pretty sure there's one over there. So I'll let you guys have a try with this, and tell me your answers to chat. Just wait for one more right answer and then we'll get started. So the people that got it right is dot 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 and 80 PL. So the answer was 85 divided by 256. So basically, notice this is 1/4, and this is 1/4 of the 1/4 squares, or 1/16, plus 1/4 of the 1/4 of the 1/4 squares, or 1/64, plus finally 1/4 of the 1/4 of the 1/4 of the 1/4 squared, or 1 divided by 256. So now, combining fractions gives us 64 plus 16 plus 4 plus 1 divided by 256, or 85 divided by 256. Now let's move on to problem 26. The first four triangular numbers are pictured. The nth triangular number is formed by drawing a row of n dots below the n minus first triangular dot pattern. K triangular number is represented by 120 dots. What is the value of K? So, remembering what we talked before, that the nth triangular number is n times n plus 1 divided by 2, try using that to find the K. Okay, so I got it right. So let's get started. The answer was indeed 15. So I said in the chat. So basically, remember that the end triangular. Sorry, triangular. Oh my God, writing is horrible these days. But number is indeed n times n plus 1 divided by 2. Now let k times k plus 1 divided by 2. That's the kth triangular number equal to 120. Solve this equation. It's a quadratic. K squared plus k is equal to 240. Then you solve, you get an answer is 15. You get k equals 15. And then from there, that's our answer to problem 26. Now let's do problem 27 now. At each square, the square in the lower left is divided on 4 congruent regions where 2 of it is shaded. The area of the entire square, including the shaded and unshaded parts, are 256 units. How many square units are in the shaded area of the fifth stage? So basically, in the first stage, basically this plus that, and then that plus that, and then that plus that, that and that, that and that, and that and that, so on. I'll let you guys have a try on how many are in the fifth, on the fifth stage. I'll let you guys have a take on this. Tell me answers to chat. Seems like you guys kind of very off, but you guys seem to approach in the right direction. Notice that the area is actually the area of the entire square, like the entire square right over here. Oops. The entire square area over here is 256. So maybe you could multiply 256 and see if it's right. Okay, so let's just get started with this question. So answer was 170.5. So basically, remember that it's one half of the area. So it's gonna be one half of this area, which is just 128, plus half. It's 128 plus this small, which is just half of this area, which is just 64 divided by 2, which is just 32. Plus this is just, so divide that, you get this area 16. Divide that by 2 again, which gives you these two areas, because that's half of the area of this. This right over here. Show you there. Gives you 8. And then continuing this pattern, this is half, take a half of this is the 4 and divide that by 2, it gives you 2. Basically, the air is getting four, divided by 4. And then 2 divided by 4 is gonna be 0.5. Adding that all up is 170.5. This is the total shaded area region. Okay, so now let's go to problem 28. The border number of n by n squared is whose edges are the border of the squares. The border numbers are 1, 1, 2, 1 by 1, 2 by 2, 3 by 3, 4 by 4, 5 by 5 are illustrated below. So now I'm gonna find what is the border of 20 by 20. Here's a really neat way. Maybe I'll give you a hint. Maybe subtracting, doing this pattern. Maybe look at the total area subtracted by the blank area to find the shaded area. I'll give you that hint, okay? I'll let you guys solve it and we'll talk about it in 7:55. what if you actually got it right while another person you were super close, but then ended up listing all the numbers from 1 to 100, which somehow he got one of them right. So from there, let's go solve the problem. The answer was basically in the form of n squared minus n minus 2 squared. Notice that this is a n minus 2. Pretend it was bigger. It's n minus 2 by n minus 2 squared. And the bigger square is going to be n by n squared. And subtract that, we get basically the formula is n squared minus n minus 2 squared. So plug in 20, we get 20 times 20 is 400, which means 20 squared is 400, minus n minus 2 squared, which is going to be 20 minus 2 is 18 squared, or 324. Subtract, you get 76. Okay, let's go to a new one. We're going to start a new chapter. Basic knowledge review. Statements. A statement is any sentence that either is true or false, but not both. Examples are Boston is a city in USA. 1 plus 1 is equal to 3. A spider does not have 6 legs. And of course, you do not have to do your homework. The following sentences are not statements. Do your homework. How do you solve this math problem? SAT test is harder than ACT test. This sentence is false. And it is a paradox. So if I say if it's true, it means the sentence is already false. But if it's false, then I mean it's true, which is contradicting. The statement sentence SAT math test consists of 54 problems is a statement. The negation or the negative is SAT math test does not consists of 54 problems. The negation of a true statement is false. The negation of a false is a true. Like, for example, if I said you don't own a bike. Some of you do, some of you don't. And the negation of it is you do own a bike. Say if I said it to you and you had a bike, means if I said you do not have a bike, it's gonna be false. And same as if it's true. Then when I said if you do not, if I said it was false, if it was true, then if I said you do have a bike, it is gonna be false. For example, from the negation of these things, the moon is not a star. The moon is a star. Of course, the moon is not a star. Not a star. So it goes from true becomes to false. The moon is a star. The moon is not a star. Of course, it's as false to become true. A spider does not have 6 legs. That's true. Spider has 6 legs. False. Of course, you can. Okay, I'll pause. Okay, let's move on. Some rabbits have short tails. No rabbits have short tails. This can be true or false. I remember true. This can be false. All rabbits are false. True. I honestly haven't seen one in the wild that has a long tail, but you could show me if you want to. But I'm gonna say it's true. I mean false. For this one's gonna be false because some at least have to have a short tail. And then these are about the statements you get in the AMC8. Like if P, then Q. For example, if I say, though if it's windy outside, then I gotta stay home and watch TV. Which happened in California. These days, this week had fires and wind. The converse is that if I can stay home and watch TV, then it's windy outside. But the inverse says if it's not windy, then I'm not staying home watching TV, eating popcorn, whatever. But the contrapositive, if if I'm not if I'm not eating or watching TV, then I'm not literally watching. No, it's not windy outside. if I say this is always going to be true, and so is this, if it's true. These are technically equal. These are equal statements. Direction. If I live in Boston, then I live in USA. If I live in USA, then I live in Boston. If I do not live in Boston, then I do not live in USA. This, of course, is not true. If you don't live in Boston, then you don't live in USA. I think you're in a different dimension. If I live in USA, then I live in Boston. Not true. It's literally the same as inverse. Contra positive. If I do not live in USA, then I do not live in Boston. Or different example. If if I live in California, then I live in Hawaii. And then if I live in Hawaii, then I live in California. If I live in if I live in California, I live in Earth. That's a direct statement. If I live in Earth, then I live in California, which is not true. Inverse. If I do not live in California, then I do not live in Earth. Well, as we can see, I'm not living in California, and I'm indeed on Earth. And contrapositive, if I do not live on Earth, then I do not live in California. True. Diagonally opposite, they're logically equivalent. Not logically equivalent are adjacent ones. Okay, so it's at the end of the class, so we'll go over this next session also. Continue it. So thank you for coming here, and I'll see you in next session. Bye.